going to focus on a few things. Now, access modifiers is something that basically every time I've done, I spend a bunch of time on. This time, I'm not going to spend so much time on because I want to spend more time on the other sections. That means already kind of filled out here. But basically, access modifiers is just something where you kind of have to learn it. And I think it's something that you honestly, it's an online course, so you can always look it up. In previous times, it was always in the exam, and since it was always in the exam, it was really, really important that people remembered what it was. This time, it's pretty much really never in the exam, or if it is, it's like a kind of hey, design-wise, why is this bad, right? But in terms of talking about this, there's a few things I want to talk about when I talk about access modifiers. The first one is why do we have them? So can anyone tell me why do we use access modifiers? For example, Python does not have the ability to have private variables. You know, why do you think Java does? Beautiful. Yeah, okay, that's good. Anything else? For safety, yeah, that's good. Encapsulation, I love that word. Convey the intent of the code, yeah. There's one big thing that I like about design, and it's to prevent people from doing bad things. It's like this kind of what I'd call like the bad actor problem, where basically you kind of it's what happens with like ethics. So what happens is like they have a process, right? Let's say this process is deploying a bit of code to production. Yeah, to prevent IS misuse, basically. And so you have this kind of process to kind of deploy something. And in this process, one of the kind of big things about it is that we want to be able to prevent people from accidentally deploying bad config. We would call them bad actors, right? Because they're trying to do something that's actively bad to our system. And so there's various different ways in place. For example, hey, before you deploy something, you have to get approval. So now what you've done is you've added like a human layer. Okay, I want to deploy this. I need now I need to go talk to someone else, and we need to discuss. And if we both agree, then we can deploy it. But you can still have a problem. They could maybe missing like kind of lie about what it is or whatever, or maybe they could misunderstand it, and so you kind of have still this problem. So the next step is, hey, before you deploy it to everything, just deploy it to 10%. And then if an issue occurs, it doesn't deploy to the rest. So you limit it. So you have these kind of like various different like limiting kind of solutions so that one bad problem doesn't take down Google, right? And so the same thing with Java. And so basically, with this kind of access, what you're trying to do is you're trying to prevent people from opening up your class and treating it like surgery, right? And tearing the pieces apart and then putting them back together, right? And so you probably saw this a bit with C sometimes. You could just kind of open stuff up and just like play around with it. As long as like it was like roughly correct, everything was good. And it's just not a good way of designing classes because it's very fragile. It's very hard to like update a class if you know that people are going to be mucking around with the internals. And so the whole point of like OOP is that kind of you're making this separation between your data or your state and your design. And this is legitimately pretty much how every programming paradigm works. Like whether or not we're talking about functional, whether or not we're talking about, imperative, it's not really a paradigm, but sure. OP, data orientated programming, whatever you want to call it, right? They all basically try to do the exact same thing, and that is to reduce state. They want to reduce the number of state in your system because state is this big bad thing, right? State is mutable. It's hard to predict. It's basically what changes. What basically if you have like one big kind of state in your system, that's a point where everything is coupled to. And so as that changes, everything that relates to it also changes. So you kind of get this like kind of I don't know what you want to call it, but regardless. And so the big kind of annoyance here around functional and OP and DOP and so on is they all go, how can I fix state? So functional is like a nuclear bomb. It just destroys it completely, right? There's no state whatsoever, right? So that's the idea. I mean, there is, but they basically say, hey, we're going to approach this and we're going to have no state. So everything's pure. And so what you have is you have composition. So the idea is that basically everything kind of returns the next state. So it's almost like you kind of have a sequence of states. So for example, you'd have like A0, and then you'd pass this to a function, and that would return the new state A1. Right? And so what that means is that you never store the state anywhere, and so all you have is transitions. So what you do is you're kind of able to remove the concept of state by defining it as like something that isn't bound to any kind of global status anywhere. But then you get into things like monads and stuff like that, and there's nightmares and stuff like that, where they kind of break all that. OP does it by basically hiding it. It like chucks it under the bed, then like puts the bed on fire and goes, look, it's on fire, and pretends and hopes no one looks underneath, right? And in OP, you can typically have this kind of big problem where people design classes that aren't OOP classes, and then they go, oh, look, OOP is bad. And like, it is to a degree, but like you have to design classes like in that kind of style to really see the benefit. And so the big thing is that basically your class should not represent some data in OOP. Your class should represent a concept. And so what I mean by that is if your class just consists of getters that just return the data inside that class, you don't really have a class, you just have data, which means that your thing is still very stateful. And so when we're talking about like access modifiers, we're not just saying, hey, let me hide this thing. We're saying, let me add layers onto my class so I can kind of represent an interface for you to interact with and for you to operate on that's separate from how the system actually behaves underneath. And so a really good example of this is, for example, I was going to give a satellite example. Let's not give that one. Let's say like a car, right? So you have a car, and this car, a very badly drawn car, has various different attributes about it, like wheels, for example. It has a frame, it has windows, there's all these kind of different aspects of how the object is structured. Now, you could design a class like this, and you could have a function called move. And the car could have a position. The car could have a ton of wheels and stuff like that. But if I tell a car to move, what I'm really doing is I'm really kind of invoking a very explicit state transition. I'm saying, hey, I know you're in this state. I want to move you into this state. And so what you've kind of done is you've kind of broken the whole idea of OOP, because now you know what the state of the system is. And you've kind of gone in and gone, no, I want to tweak you around and change you to this state. It's no real different than if you basically just have public variables. And so the point is that you want to kind of represent the car as if it's like an actor in a play. And you don't tell an actor exactly where to stand. You tell an actor what you want it to accomplish. So you tell the car, hey, instead of just moving, you say, hey, car, I want you to press on the steering wheel. I want you to turn the steering wheel to the right, and I want you to press on the accelerator. The car can figure out what those actions actually do to the system. So what you're doing is you're performing actions on the car which result in state transitions, but you're not explicitly making those state changes, if that makes sense. You're not saying, hey, car, I'm going to move you to this position. You're saying, hey, car, I'm going to accelerate you, which will change your acceleration, which will change your velocity, which will change your position. Right? And so you kind of get this, I don't know, this encapsulation away from it, if that makes sense, hopefully. And if you're able to do that well, you end up with a very, very, very nice system. And because what that means is that your classes become abstracted just well enough that they're extremely reusable. Because they don't depend upon their data. They depend upon their behavior and based upon what they can do. So what that means is if you needed it to do something else, it's almost very easy to do that. It's very extensible, right? But if you also want to go in and change the entire logic of how the system works, like the entire, like how the data is stored and all that stuff, you can, right? Now, some getters are always useful. For example, like, hey, get me the ID of the car, get me the name of the car. Like, that's common, right? But there's a bunch of stuff that, like, if you're following real OOP, we typically avoid, and that could be things like, set, for example, like a function like get me all the wheels of a car. Because the question is like, well, why do you need the wheels of the car? Like, what are you trying to do? And it's like, well, I want to try to get information about the wheels of the car. And so if you're doing stuff like that, well, then you're really trying to ask the car about its wheels, which is kind of like a weird thing to do because maybe not all cars have wheels. And so you're kind of now restricting your design, you're kind of coupling this concept between the two, right? Um, I mean, typically cars always have wheels, but who knows? Maybe like a boat car or something. And so I think with anything, when we're looking at design here, the big goal in the end is not to kind of draw a big circle over everything. We're not trying to generalize, right? We're trying to find what makes all these objects unique and trying to draw just a nice little kind of section around it. So for example, rather than drawing like, let's look at this. So this is a good example. So let's say, for example, we have cars and we got planes, right? So cars, planes, and we have, I don't know, boats. All these objects move differently, but they pretty much have somewhat similar methods for interaction. So a boat and a car is pretty much the exact same thing. They have accelerators. They typically have some sort of engine. A boat is powered by a turbine typically, but it's pretty much just an engine with a fan on the end, a big fan on the end. And so effectively in the end, they're kind of pretty much the same system. And so in terms of how I'm interacting with it, a car and a boat to me is no different. And so these are really good candidates for like a kind of a general class. So you could define a general abstract class that sits on top of both cars and boats. That makes sense. But that's not to say that you have to go and go, okay, well, a car and a boat and a plane. Well, they're all pretty much the same thing. I mean, a plane, sure has like 300 buttons, but I mean, that's kind of like a car. No, like a plane and a car are functionally very differently in how you interact with them, right? You don't have to make everything the same, right? You don't have to go, okay, well, I've got cars and planes. I need them to have a base group. Okay, then I need that also to have a base group. And then you end up with this tree, and at the very top, you have an atom. Okay, so now everything derives from an atom, and then now you're going even higher in atoms. You're looking at like freaking quantum physics, and you're trying to model everything in your system, and you're going as high as you can. Oh wow, look at me, I can model everything. Everything's got this complicated class relationship. It's not about trying to like do that, right? You want to keep your relationship simple. If you're ever going more than 1 to 2 layers of inheritance, you're probably gone too far. And so when we're kind of designing these systems, what we're trying to do is we're trying to grab two items that are very similar to each other. They've got a lot of things in common. And we're saying how we interact with these objects is similar. So let's generalize on how we interact with them, but keep what they do distinct. And that's really what abstraction is. It's pulling out the context of where you can use the object and generalizing that context, but keeping the specific implementations inside of the classes. So what that means is instead of having if statements outside of the classes, you go, hey, if the type is equal to, let me just type this. If type is equal to boat, do like some action. If type equals car, do some other action, right? In reality, all the difference between these actions maybe is that the boat, for example, maybe spins a turbine and that kind of does some random like interaction with physics or whatever, blah, blah, blah. And the car just kind of causes the engine to, I don't know, I literally know nothing about engines. The engine to do something, and that causes some, I don't know, kind of energy in the system. I don't know. And it causes the wheels to move, sure. I studied physics, but I know how cars move. And so, sure, how they kind of interact with the world is different, but how I'm interacting with it, how I'm going to use these classes is the same. And in reality, yeah, Jeez Louise. And in reality, you're not going to be simulating the full interactions between a boat and the water. You're probably just going to be like, if you're building a game, you press the on button for the boat moves forward at this rate. Like, you're not really going to be looking at like the water and like simulating how that kind of movement works, right? And so for that reason, they work pretty much identically. And so in that case, I mean, you probably even just have like an acceleration on both of them, and then they'd share the same kind of like movement code, right? But boats have this kind of like vertical kind of drift as well as they kind of go up and down the waves, right? Whereas cars are kind of reasonably stable. So maybe like you have a little bit more complicated behavior. Again, who cares? And so the point here is you're trying to grab this and you're trying to abstract this away, so you kind of have this unique kind of parent class here. And so basically this if statement becomes based on the type. So rather than like this where you specifically check in the type, this becomes like an inheritance thing. So what you have is you have a single function, which I'm just going to call x here. And then the boat class overrides this function. And so does the car class. So what you're getting is you're getting this concept of overriding. So what this means is that the boat class can grab the default function here, change the behavior to what it wants, and then now it's able to kind of add its unique spin on things, right? While still keeping the system behaving overall, so it's pretty much the same. Anyway, that's basically a bunch of fancy words for saying it tries to hide things, right? And we're talking about that a lot. It's hard concepts, I think, because I think a lot of the stuff you kind of got to see it. So when we kind of do some examples, hopefully you'll start to see why it's so much better. And what you'll probably notice is that a lot of these concepts aren't unique to OOP. OOP just kind of takes them and applies them to classes. And you see a lot of these concepts exist in pretty much every language and pretty much every kind of way, because it's very useful to do this sort of generalization. So, in Haskell, you can kind of do these kind of operations based on like, I mean, it's generics and Haskell. Generics aren't the same thing, but they're roughly the same kind of idea. And even in Haskell, like, or a functional language, right, where everything's a function, what happens is your functions kind of become like your generalizations. They kind of become like your parent classes, your superclasses. And so what you do is you have like this kind of concept of, hey, if you want to call this function, if you want to move, all you need to do is you just need to have this kind of attribute on the system that tells me how to get your velocity and how to get your acceleration. If you have those two things, if you have a function to get the acceleration, a function to get the velocity, I can tell you your new position. And so therefore you have this kind of generalization. And so this kind of the concepts still apply. Even in C, people typically end up writing that same kind of idea, right? They kind of push this if statement inside of a function rather than kind of having people to keep copying it outside the function. I don't have my VS Code open. Let me... I'm not going to do it that way, just in case that the previous VS Code I had open was any kind of solution. Thank you, Xcode. Do you mind, like, not... Okay. Come on. I'm just going to let that sit for a second. Okay. And yeah, so that's basically it. That's fine. And then what we're going to do is we're going to jump into shapes, and we're going to have a look at an example. And then we're going to jump into looking at kind of creating some database to store some employees, which is similar to this week's lab. Awesome. Yay, it works. Okay, tutor work, computing. There we go. Okay, so I'm just going to create a very simple tutu. And what we're going to do is we're going to start creating some shape classes. So the first thing is source/shape, and create you as a... I'm going to open up a Java project just so it recognizes that Java's... Okay, it's fine. I'll just do it here. And so what we'll do is we'll create one called shape.java. I mean, it's fine. And we'll create this class called shape.java, and we'll chuck it inside a package like shape. And the kind of question here is if we also have a rectangle as well, and that's not where I want to put it. And we also have a circle. Can I now add you? Yes, I can. And I also need to give you a package. Thank you. That's not how you write packages. Wonderful. Okay. So what do you think I can typically do to a shape? What kind of questions or actions do you think I can probably do to a shape that's interesting? Area, perimeter, good. Height, width, scale, good. So they've kind of got a few interesting things. So the thing about height and width, right, is a shape as a concept. I have a polygon. Does a polygon have a width? Not really. Like you can kind of define one, but by defining like a square around the polygon and then saying, well, the square is kind of the width of the polygon, like kind of like a circle, right? But it's not necessarily the same thing. Height and width is kind of in this 2D, especially if you're dealing with 3D. Now you're dealing with 3 dimensions, and a height and width no longer really makes sense, right? And so that's the first question that we asked about is what kind of shape are we talking about? Anyway, so let's get into that in a second. I like the concept of scaling. So we'll add scale, and we'll give you a... we won't give you any arguments for now, and we'll come back to these. And then we also maybe have like a rotate, which I'm not going to write because I don't want to do rotation matrices. OP course. But we'll keep it for the sake of it. And then we have color, 2D, 3D sides. Okay, good. Now, color is actually a really good concept. The first thing I would say about color is I know we typically include it in these kind of examples, but I would say I look at a shape, color's not really important to that shape. It's some attribute of me drawing that shape. I probably wouldn't store it with the shape itself. Unless, I'm entirely focused on drawing this. If this class is entirely focused on drawing, if it's a graphics class, that, hey, I'm drawing the shape, I'm going to then render it, 100% chuck the color in there. But otherwise, it could probably just be an attribute that is stored somewhere with the shape to say, hey, when I'm going to draw this, I can just go draw for this color, right? That way, you kind of keep everything restricted, and so that way I don't have to search a color if I'm just looking for math on it, right? But yeah, position is a great point. So position is another thing, right? So when we're talking about position, we're talking about an offset from an origin, typically. So you have these two concepts. You have what we call local and world position, typically, in whatever system you're talking about. So local is like, hey, relative to some kind of hierarchy, where is the position of this object? And world's like relative to 0, 0. So for example, you have like a human being, and this human being stands in some kind of earth here, right? Now, the head could have a local position to the body of, let's say, maybe like plus 0 on the x-axis and like, I don't know, like plus 20 on the y-axis, right? Jeez, I really can't draw today. Anyway, so plus 0, plus 20. Whereas the absolute position of this object would be like the radius of the Earth plus, the person's height. So it would be, r plus 20, if we're presuming the height of the person's, this magical 20, right? And so you kind of have this concept of local versus global. Then, okay, well, where's the Earth located? Well, maybe we say the Earth is located at some kind of r prime away from the center of the universe, which is some kind of random black hole, blah, 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 right? And so you can see like this kind of concept of position is so relative. And so again, I wouldn't really say position is something that belongs to the shape, because position is where I want to place the shape. The shape doesn't care where it's placed. The shape just cares about its dimensions itself, right? And so that's like saying that could be auxiliary to the object itself. And so it's actually this idea of what we call composition versus well, it's not really composition versus inheritance, but it's the same kind of idea. It's like, do you compose many objects together, or do you kind of have one big monolithic class? And I think composition is much easier to begin with, and it is typically the one I prefer, because what it means is you have kind of a little bit more repetition sometimes, just a little bit more, but in terms of that, your classes become a lot simpler, and they also kind of do one thing very well. And so it's not like, hey, well, okay, I have to spawn a shape here, But okay, the shape requires a position, but because it doesn't have a position yet, what I have to do is I have to create it with -1 and -1 so that all of its calculations still work. Because if they don't, then maybe it throws an error or something. Okay, and then I also have to give it a color, but like I don't know the color because the user hasn't selected the color yet. Okay, so I'm just going to give it like a default color. And so like there's a lot of complexity there that's annoying, or you have to kind of like ignore these properties, and it's kind of like, that's not really like the point. Right? Whereas if the auxiliary properties, it's really reusable, and it's kind of like, hey, I need a shape in multiple places in my code. If every time you need a shape, you need a color, add the color, right? And keep things simple. Anyway, so position, color, they're both things that are useful, but not necessarily what I would include right here. But 2D, 3D is probably one of the best things I was thinking kind of aiming for here. And here's what I would do. Don't generalize your shape across dimensions, because there's no need. Have a shape 2D that has area, perimeter, scale, rotation. Double scale X, double scale Y, double rotate X, double rotate Y. I'm just going to give us a body just for the sake of it. And we'll talk about abstract in a second. And so you give this a definition, and then you have a shape 3D, a shape 4D. Because the thing is that if you want to group these together, right, most likely what you're doing is you're going to group them maybe under a generic shape class, but the questions you have for the generic shape class are going to be very different. Because you're not going to ask the 3D object, hey, what's your perimeter? That's not a common thing to ask. The surface area, sure. But the surface area is not the same thing as area, really. Right? I mean, it kind of is. I mean, I guess, okay, sure, it's analogous. But like, for example, scaling it, do you really want to have all these like extra arguments here? Okay, well, I've got to handle 3D, 4D, so either I have to pass like an array of scaling arguments, then each class has to validate those scaling arguments, check the count's the right size, and it's really clunky to use and no one likes using it. Or you just have something that's very simple for people to use, and you suffer with the fact that there's just a little bit more checks, right? It's about like coping and kind of straddling the line between too much of an inheritance chain and between simplicity. And simplicity actually kind of wins because it makes it much easier to change the code over time and also makes it kind of follow this OOP style much better. And so you kind of see Java take the opposite approach sometimes. What will happen is they'll kind of keep abstracting things, and it's actually been a mistake. They've had to like deprecate probably almost about 10% of the language's library because what they've done is they've abstracted it too far, and they've gone, expletive here. Help! I need I can't go any further. What do we do? Oh my gosh. Okay, well we're gonna have to define now a new interface. So classical examples, if you want to look up, observable. Fully deprecate now. Why? Because they're like, okay, if we want something that's observable, it's a class, which means if I want to make my object observable, which means I want other things to be able to look, like, wait on it. Observable is like, hey, I have like a weather sensor, right? And this weather sensor is, this windmill kind of thing. And it spins around and tests for like the pressure or whatever you're doing, right? And then this is going to periodically send updates to some kind of microprocessor, right? Now, typically in modern systems, they do what's called like a poll, which is basically like almost like a pool model. Basically, every like millisecond, the system will kind of ask for new data and be like, hey, do you have data yet? Are we there yet? Are we there yet? Are we there yet? It's like really annoying and like really not really energy efficient. It's like really expensive and stuff like that. But it's very easy to write and very just very simple. When you got to do things like observables and stuff, you got to set up what's called an interrupt handlers, and it's a nightmare. Anyway, nightmare for a CPU, very easy in Java. And so the whole idea of a observable model is that this tells it when it's done. So it's what we call a push model. So you're pushing updates rather than pulling them or polling them. And so you learn about this later on. It's a pattern. And so the problem with this observable class is it's a class, and you can only ever inherit from one class. So what that means is if my object is now an observable, which means things can listen to it, that's all it is. It can't be anything else. It can't be a shape. It can't be a car. All it is an observable. And when we look at the kind of behavior inside this observable, we also notice one other thing. And that one other thing is that what happens with this observable is we have this concept called notify observers, which goes off and calls a function and says, hey, observers, something has happened. And the thing about this notify observers, it's called observer.update, something like that. It's not called observer.update. I remember the function, but there's some kind of function that happens. I could find by reading through this, but let's not worry about that. And so the idea is that you kind of have this notify function that they get. Here we go, observer. That's what I'm looking for. And so each observer is an interface. Now, interfaces are great because we can implement as many of them as possible. But there's one problem that I hate with this interface here, and that you get given the class that changed, and you get given a freaking object. This is useless. I don't like an object. So what am I expected to do with this object? Am I expected to type check the object? And then now everything that has an observable has to follow the same standard for this object to tell me what it is? What if I have two observables that I want to listen to, and these two observables are going to give me the same object argument, and now I have to check the type of the observable to also determine what to do? Like, this is just bizarre. And so typically a much better way of doing this is that what you do is you bind specific functions. So what you would do is you say, hey, I want to observe you that something has happened. And so you'd go, okay, I want a position observer. And you say, okay, hey, this is interface, not class. Hey, you want a position observer? Sure. Here's a function. Position changed. My position used to be, maybe this is like a vector 3D, right? It used to be old, now it's new. Not only is this simpler, it also doesn't have a super base class. We've kind of removed the abstraction. We've removed this kind of concept of inheritance, and we've replaced it with composition. And this is just so much easier to use. Not only is the name clearer, not only is the arguments clearer, and there's no type checking required, and just it's so much nicer. You could pass arguments extra here as well. But there's a really nice thing about interfaces, and that's this concept of anonymous functions. And you learn this later on. But what you could do is you could say, hey, I want to add an observer, right? Like add a position observer or something like that, right? And you can actually pass it a function as an argument. Like you could create a function on the fly, old, new, and then give it like a body of text like this, right? And then this function that you create on the fly, you could have context to all the variables above it. So for example, let's say you're creating like a weld. It really is going to give me errors for everything, isn't it? Anyway, it's fine. Just pretend the errors don't exist. New position. Anyway, and we're going to call this old position. And so, for example, maybe you got like a weld, blah, blah, equals a new weld, and you got a bunch of other stuff, and at the bottom you got like weld observer, right? And then you got like a kind of a grid that you're creating, right? And you kind of splitting up this grid of positions, right? Add like square, right? And maybe this square is for the player. You want to like create the player somewhere. And then every time the player changes its position, you want to update its UI position. So you go, okay, player square equals this. This is like a pretty terrible way of writing this, but you get like the rough idea, right? You can kind of have this access to the square. And you can say like player square dot move. And you can say, hey, I want to move the square to a different location. I want to move the UI. UI is typically very like, hey, move here, move there. Or like typically at that level, because you kind of very specifically, like the state is the point of it. Anyway. And so you can say, hey, I want you to move to the new position. But maybe like it's relative or, offset, like apply. Maybe it's like a game or something, right? So you want to like apply some kind of like slow movement. So you want to like, hey, I want to apply a force or like apply a velocity or something. You can like calculate the velocity based on the new position, the old position, and how much time has changed between them, right? And so can you kind of like maybe this makes sense of like how this is very nice, because you can kind of have this like, hey, rather than having this big class inherit, okay, this class is an observable and so on, you kind of have like a splintered concept. So everything kind of gets its own unique little thing. And then combining them together, you make the whole. So for example, if you want an object to have a position, you could have a thing that's called like transform. Now, this is a component that says, hey, I would probably not make this interface, I'd probably make it a class, right? And you say, hey, you want this entity to have a transform? Just add this component to it as like a member. And this transform will handle the position, it'll handle the rotation, it'll handle all the rendering required for that, it'll handle the scaling, it'll handle all of that. And I got a shape, I can add a transform to it. I've got this, I can add a transform to that. It's a common thing that I can use anywhere. It's very useful. And that's kind of the whole point of this. And so, for example, we can call these abstracts, which will mean the classes be called abstract. And what we've done here is we've just said, hey, okay, a shape 2D though, sorry, let's see. Will these be has relations or will they be interfaces? They would be has a. Like the transform would be has a. Like this object has a transform. But the like observable would be like this object implements this observable. Yeah. You could make like the transform interface, but you can probably go a bit crazy. As of anything I'm saying here, like you can take this with a grain of salt. You don't have to trust me. Like learn this stuff for yourself as well, right? Like take my opinion about this stuff, look at the lectures, look at all this stuff, and kind of collate and come up with your own opinion. And so with this kind of area here, we're saying, okay, a shape 2D, the area is defined based upon the two-dimensional class. I'll let the class define that. A parameter, that's defined based on the two-dimensional class. I'll let the class define that. But scaling and rotation, maybe the shape 2D can handle that. Because to me, the scale is something I'm going to add to the area. And same with the perimeter. It's like an abstraction on top. So what I could literally have it so it's like these are like private functions, right? Hey, here's your area, here's your perimeter. I mean, they can't be private, they're to be protected, When protected means the subclasses can access them, but basically no one else can, except when you're in the same package, right? So protected is really, really useful for this specific thing. And so the subclass could provide its definition for this, and then I could scale and rotate it. But again, what you've basically done here is you've just decided to use an interface, but you've cheated. So what you could really do is you could really just create like an interface, right? Called iShape2D, and say, hey, if you're a shape, you have to have these two functions. You don't have to add the I at front. That's just me being using C# a lot. So my brain goes, hey, add the I. Interface. So you have this interface, iShape2D or just shape2D or whatever. And then what you can do is you can say, okay, well, a shape, right? For you to have a shape that needs to exist, it needs to, or I wouldn't even say shape, I should say like entity, right? Maybe it's say, here's my entity class, and this is like a class, for whatever reason. This entity class, what it's going to store is it's going to store a shape. This is maybe for the collider. And so this will define how this object collides with other objects. This example is completely on the fly, so we'll see how it goes. And so what you're doing is you're defining some kind of collision. So, okay, for example, let's say you have some kind of object, like for example, I don't know, a square. And you want this square to be colliding with some kind of bullet, right? Which doesn't really look like a bullet. Art degree. Anyway, and so you have some kind of like bullet here, and this bullet's like flying at some kind of velocity, right? And so you want some kind of collision here. So maybe what you do is you define like a box collider, like a 2D collider on this. And then also the bullet has like some kind of like circle collider at the front here that defines, hey, when these things meet, they're going to collide. And so you have this kind of concept within shapes that says, hey, are these things colliding? So maybe that's like another function as well, right? And so what you could do here in your entity class, you could have some definition of the collider, and then you could have some kind of transform that represents the position of the entity, the scale of the entity, and all that kind of stuff. And so what you've done is you've kind of separated these two concepts. And so the shape is purely just to define, hey, what's kind of the rough idea of how this object kind of exists. And then, hey, I want a circle collider. Okay, I create a circle. And to create a circle, it requires a radius and a radius. Like an oval has like, you know, the semi-axes and major axes and whatever the heck. But for a circle, it's very much just a radius. Right? Pi r squared is going to be your area. And so if this implements I shape 2D, there's my area, there's my perimeter. You know, return, is it 2 times radius? I actually do not remember. It was like 2 times pi times radius, something like that. Maybe it's like 4 pi radius. Something. But this is pi r squared. Radius. 2 times pi times r. Thank you. And then this is pi r squared. And so what you have is you have like a very nice class. Like, oh, this is beautiful. I love using this class. This is nice. And it defines a very common behavior of, hey, this is a circle. You can ask these questions. You can, it has radius, there's perimeter. But really, this class isn't doing anything yet. This is just data. What's beneficial is the fact I said, hey, I want this to be a collider. So what I've done is I've done the opposite of abstraction. I've done specialization. I said, all this is a collider. Right? That's what I was doing here. All I wanted it for was a collider. So I create an I-shaped 2D collider. Rather than trying to start at the top, I start at the bottom. If I later on need this concept of a shape 2D that's both a collider and a normal shape, then I can do that. But right now, all I need for my class is a collision. So all I do is the collision. And so now I can actually ask it beneficial questions. I can say, hey, does this overlap another shape 2D collider? Now, this is quite a complicated question to ask whether or not two shapes overlap, because guess what these two shapes require to be overlapping? We require the actual position of the objects. We require so much information. So for me to ask whether or not these collisions are overlapping, I need to know the position of these collisions. I need to know a ton of information about it. But that information isn't actually beneficial to the collider itself. That's not state of the collider. Right? That's state relevant to the collider, right? So the collider itself does not need to manage that. So I can say, okay, as a collision object, you know your size, you know your dimensions, right? Maybe this actually also has a local transform. Like, that's fine. Like, typically your colliders within it will actually have a local transform. That's very common if you're building it like a game engine, right? And you have like, hey, how much is your collision offset within your object? That's very, very common. You probably wouldn't put it within each class. You'd probably have like some kind of generic collider class, right? Maybe, I don't know, maybe not. And so what you could do here for overlapping is, therefore, because of that transform, you would inherently know it's the world position. But even if you didn't, you could just pass it. Here's your world position. Here's where you're located. Here's your collision. Here's where you can look at your position from. And then you could give it like another entity saying, hey, given this other collider, do you collide, right? And so the thing about all collision is this. You're basically, it's quite complicated, typically, collision. And you can see a very good example of it in the assignment, which is kind of why I'm talking about this. Let's just jump here, then we'll jump to the specification. No, we won't. We'll do it this way. And we'll just look at one class within this assignment here, just for the sake of this example. And what we're just going to look at, and actually I'm not going to do the DB because I think this is more interesting. I think this covers the same concepts, is we're gonna look at this math help, but we're gonna do a little bit more. We're gonna do like a to string and talk about equals and stuff like that, but very small. We won't spend more than 10 minutes on that. So you have these like distance equations and stuff like that. And the thing that like it's kind of interesting is this concept of visibility. Now, visibility is basically a collider, right? You're basically kind of drawing a line between two objects and saying, hey, does that line collide through another object? But the thing about this collision checker here, is that you give these positions of these objects, and then it calculates like their real world positions, which is Euclidean, and then it like figures out whether or not they collide. And when you're defining like this, you don't actually have to like if you actually had something like for example, a circle collider, and you had your kind of ray collider, which is just like a line, right? You could define a ray, and you could say, hey, here's the properties of this ray. Do you collide? And legitimately, what you could actually have within your circle as a collision thing is it's not even that crazy to have, if you have given an entity here, to actually just check its type and say, hey, if the collider is a rectangle collider, I know how circles collide with rectangles. Because what we're not doing here is we're not trying to generalize collision, because generalizing collision is a really bad idea, because collision is highly optimized for certain shapes. A circle in a circle is an extremely optimized collision. We're not trying to generalize that, because you lose those optimizations. What we're trying to do is we're trying to make it so that only the classes that know about the collision care about the collision, right? And so this circle collider can decide all the logic it needs to collide with a rectangle. Now, what you'll actually find is you'll find that obviously when the rectangle wants to do it, it basically wants to do kind of the same thing, right? To ask whether or not a rectangle collides with a circle, it's the same thing as asking if a circle collides with a rectangle, right? And so it's kind of a slightly bad example in that case. What you'd probably do is you'd probably like have like a bunch of overloads that would take two colliders, and then like they would be outside the classes, then they would look at the two classes just to handle that. But like, sometimes you don't always have this like one-to-one relationship that goes back and forward. And so what you can do is you can kind of break this down. And so it's okay to have instance ofs. And you'll probably use instance of in the assignment and in the project. But what you want to do is you want to put them only where they're needed, where they're at the bottom of the hierarchy, where you've kind of specialized the class. So here's like one final example to wrap this all up. Let's say you have some kind of world class. And inside this world class, you have some kind of series of variables. Like, for example, you have a list of entities, right? And then you also have like some kind of update function. And so what you're going to do is you're going to go for each entity in the list, right? And you're going to update the entity, maybe like update, right? And again, it's going to be errors because entity is not defined, this is not defined, blah, 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 blah. Actually, this is kind of defined. Why not? It's fine. All right. So you have update your entities and you're kind of looping through and update them. One thing you could do is you could be like, okay, what I'm going to do is I'm going to add a bit of behavior and say, okay, if the E is an instance of a vampire, then I also want to call a different function, right? I want to check whether or not this vampire is close to garlic. If the vampire is close to garlic, I want the vampire to run away. So then what I have to do is I go for all the entities again. And I go say, hey, if E2, I guess. Ugh. If E2 is an instance of garlic, then run away. Do you think this is good code? Can you notice any kind of issue with this, from your opinion? What do you think's bad about this? I'm checking all the type here and here. Yeah, all the curly braces, yeah. So there's a lot of nesting. Behavior entities in the world class, yeah. What about... how would you add the code if you had this to do this 100 times? would the complexity of this function massively increase because now you're modeling the behavior between all entities inside a single function? That's also true. So you got the performance considerations as well. So a better way of doing this is to say, hey, the vampire wants to interact with it's slow, yeah. I mean, it's probably a little slow. The vampire wants to interact with entities? Sure, let it. I'm going to give it access to me. And then the vampire can go, hey, I want to get a list of entities. And I want these entities to be of this type T. This is generic, so let's actually not do this. Let's just say list of garlic. There's a better way of writing this. Get garlics, right? But like, this is still kind of bad because you got to write one for each class. There's a better way to do it, so you only have to write this once rather than having to write this for each type. But like, we'll get into that later. Let's not go there. Let's not blow your brains too much. And then this can kind of do the loop, right? And so if the vampire wants the garlics, it can go and get the garlics. And so what we've done is we've moved all that specific behavior to that class. And so if I have to do that 100 times, this function does not change. What I've done is I've distributed the work out to multiple classes. And I've separated it to where it only matters. And so my classes can do what they care about without me having to care about it. I'm just a world. I shouldn't care whether or not there's vampires in my world or garlics. That's the decision of the vampire/garlic to decide. So it's the separation of concerns. You only do things to objects that are concerned with them, right? If you're not concerned with it, don't worry. Okay, this is definitely gone off rails. Was not what I was originally going to talk about. But I was like, I don't know, my brain just was like, this is interesting. This is pretty much the same kind of idea. But let me just kind of very briefly go over like the kind of real content of this tute. I'm sorry for sometimes deciding just to not do the tutes properly. Anyway, hopefully they're slightly more fun because that's kind of, you know, the tutes are somewhat boring sometimes. So let's very simply create a manager and some employee classes just for the sake of that. Okay. So what we're going to do is we're just going to now I'm going to delete these kind of files because these files aren't too useful in the video. We'll go through them, right? So you can look at there. Maybe I'll put like a proper example up with like some examples if I find it. Okay, so I won't spend more than 5 to 10 minutes on this. We'll see. I don't know, you know, some very bad time. So if we have employee class, we can define an employee here, and we can just basically say, hey, what does this employee have? Oh, geez, the wrong button. I want to do this. So Cameron, tell me properties of an employee. For example, what would you normally have if you're an employee? A name, good. I like the idea of name. Salary, wage, good, good, good. So name, you also have a double for the salary. What's the salary measured in? Let's say dollars, right? I'm not going to really pay people cents, but just going to say we're paying people dollars. So salary measured in dollars, which means this doesn't have to be a double. It means it's going to be like a long. This kind of matters because in precision of money. Anyway, so you have a name. Is this first name, last name? Yes, it's a first name followed by a space. I would say all names joined by a space, i.e. Braden, Rowan, Woody. So you see what I'm doing here? I'm not just saying this is the employee's name. This is the salary of the employee. Everyone can read that. What I'm doing is I'm going, hey, here's what makes this different. I'm treating the reader with a bit of respect, is to how I like to put it, right? I presume they can read the code and they know what a name is, right? And so what I'm doing is I'm giving them that respect, and I'm saying, hey, here's what you don't know about it. You don't know the fact that it's a full name. You don't know the fact that salary is measured in dollars, right? Keep going. A working ID. That's a great one. unique employee ID, or just unique ID, consists of a UID v4 standard. For example, that's just a normal standard. Great. I read it. I now know what it is. Maybe that kind of helps you kind of understand why we're doing this, right? Start date, end date. I like the concept of start date, end date. I don't really like putting an employee class because to me, managing when the employee starts and ends is kind of probably a different system, because if the employee starts and ends multiple times, it gets very complicated and very annoying. So I'd probably have like a different component that would be like, hey, here's this employee, here's its start date, here's its end date. And so like that can manage that. But like that would probably also manage salary. Okay, sure, why not? But we'll just put that here. Honestly, it doesn't really matter. Liquidate. Start. End. Okay. The start, the hire /fire date of the employee. Now this isn't useful. So what I've done here, actually wait, I can ask you, what is wrong with this comment? Well, how could I better write this bit of code here? These 4 lines. Is there a better name I could use for the variables? Is there a better way I could write the comment? Is the comment even needed? Tell us what the date format is. That's a good point. So the date format is UTC, which means 0 offset. Like we have plus 10 hours. Another thing we could do, hire date, fire date, or leave date. Yeah, if we're presuming our employees can leave of their own free will, which, you know, who knows. And so now, date format is UTC. I know someone reading this knows it's a date. They can read the context, they can understand it. Private position. This is like the next one. What do you think is wrong with this string here? What's kind of, if I'm using this string, what don't I know about it? This is the position that come at the end, like maybe executive, I don't know, junior, whatever. What all the positions are relative to each other. Beautiful. Don't know the possible positions. So the possible positions was the one I was thinking of, but the relativeness is actually an even better answer. So the possible positions is like definitely the answer I was looking for. We don't know the possible ones. We can use an enum. We could use a string. We could use a class. We could use some kind of like array of them. And we say, hey, it's been inside this array, whatever you want to use, right? We could even list them. Listing them is fine for your sake in this course. Don't worry about it. You know, lecturer, associate, lecturer, so on, is one of. But like, it's probably better to define an enum. And an enum is amazing because what they let you do is they let you grab this kind of context and they go, oh, do you know this behavior here? Let's actually give it a real name. And so you can have lecturer, you can have associate professor. And not only that, you can also give it functions. You can give them variables and fields. You can say, hey, for you to be a private position, you have to give me a code. And this code is like maybe like a payment code. I can just call it that. Payment code. Hey, you want to get paid? This is your code. Oh, it's probably just going to be called pay code. Right? And then we return pay code here. And so now what we can do is we can say, okay, the lecturer is maybe standard pay lec. The associate professor is standard pay associate lec. So what I've done here is I've not only been able to very specifically specify the position, so then this becomes employee position, and maybe let's say we want to give it a default. I no longer need this, and I probably don't even need a comment for this one, right? not only can I never make a mistake on which one I choose from, I've added unique data to it that's useful. And enum is not really about behavior. Enum's kind of like a data class, right? You can add like random stuff to it. And this kind of stuff is very useful to me, and it prevents me having to put switch statements in my code. I don't have to check all these types. I don't have to do switch statements. They're just right here. And I feel bad because of one of the exam problems last term, there was, I say I feel bad, so it's actually really clever. There's two solutions to it. And one of the solutions was like a very kind of OOP style, and you had like tons of classes and everything, right? And it was pretty much the same amount of lines of code as using enums, and you can kind of like use functions inside enums, and it's just a really cool way of looking at it. They're really powerful. So looking at enums is definitely a recommendation. And so what you notice here is I've got all these kind of these various different positions. And the first question I have is, when I'm constructing my employee, what information do I know? So I'm creating this employee class. Which of these things do I know immediately? Do I know all of them? Not leave date. Beautiful. So I'm going to add a constructor, and I'm going to do this the lazy way. I'm going to add a constructor for everything but leave date. And I always put my constructors at the bottom because, you know. Now, okay, let me define a getter and a setter. Should I have a setter for the name? Is that a thing that happens? Do people change their names? Yeah, it's a thing that can happen. Sure. What about a setter for the hire date? Is this a thing that can happen? No. So remove it. And for some reason, it always likes to change the freaking. I'm of a preference where I don't like putting any functions in my constructors, because constructors shouldn't do as little work as possible. They should have no logic inside of them. But there's many reasons why, and it's way too little time to go to that now. So I'm going to that next week or the week after, when we talk about constructors and exceptions and stuff like that. And so kind of the big point of all what I'm kind of covering here that's okay. And that's a whole other rabbit hole. So I will kind of briefly give the answer without going down the rabbit hole. But basically, when you define these inheritance relationships, it's better to think of them as two separate classes than to think of them as like a special type of class. So when the parent interacts with the child, when the child interacts with the parent, I mean, the parent rarely interacts with the child, but typically when the child interacts with the parent, right? And I call them children and parents just because of the way I think. But you can call them superclasses and base classes if you want, or derived classes and superclasses, I guess is the actual terminology. Anyway, so the idea is that you have these kind of interactions between these two. They're very much like different classes, because what they do is they have function APIs that you have to uphold. Oh, if you call this function, you have to do these certain things. You have these contracts that you have to agree to. And you learn something called design by contract later on, which is, you know, kind of the whole idea. But like, hey, if you call this function, you have to pass this argument. This argument has to follow these rules and stuff like that. And you get into trouble when you break them. You know, exceptions and all that nastiness. But the kind of big idea about all of this is that these aren't special. The fact that you can override methods is kind of slightly graying the lines, but they're still different classes. So a child or a derived class can call the setters for its parent class or its superclass. That's perfectly fine, if it makes sense, right? Typically, you don't really find it happens that much. And it's kind of cool how it works. And I'll show you more examples towards the end of the assignment when we can kind of look at the assignment. But there's one example that I could really kind of give. And that example is I go and add a manager. And this manager is an employee. but it has one thing that's unique. I mean, I'm sure it has many things unique. I think in this, an example in the tree has many things. But anyway, in our case, we're just going to say one thing. And that one thing that's unique is that its name is always appended with manager. So it would say like manager Braden, manager you, or maybe like manager or whatever. Or, you got doctor, right? You want to add like doctor. Like you got this like suffix, right? Professional suffix. And so in this case, you can do the same thing with setters, and that typically happens. So if you want to change a setter's behavior in some way, you want to add some kind of bounds to it. For example, it's say you can add some behavior. What's a good one here for setting? We'll say when you want to set the, I don't know, the position, maybe. We'll say, hey, if you want to set the position has to be like a manager position, right? Otherwise, you want to do something, throw an exception or something. So you could go like, okay, void set position, right? I don't think set position is defined in the parent. Let me just define that now. And with this set position here, and this takes in a new position. Employee position. What we can do is we can say, hey, if position, then maybe have some kind of function to determine whether or not it's manager, is manager position, or whatever. Then you can do it. Otherwise, you can throw an exception. Why? You hurt me like this. Sad face. And what you've done here, super.set position pos, is you've kind of able to kind of have this very awesome kind of extra restriction on here. I mean, there's various different restrictions here about like kind of there's nothing that will make Java docs, but you don't have to make Java docs. You just have to make the comments. That's what the course calls them Java docs. It's probably not the right terminology, but they just mean the comments. And so they mean the comments and everything. So like this, for example, add the comments. Create a new employee. And if you have nothing interesting to say about any of these things, don't talk about them. Don't just say the name of the employee. But you do have interesting things to say. Space separated. I don't know. I name components. All names are joined by a space. Sure, that's fine. And then salary. I have nothing interesting to say about that. Or maybe it's just it has to be positive. Right? Like this is for interesting things. Has to be unique. I actually don't like saying has to be. Salary is measured in dollars and is positive. ID is unique. So, yes, but it's worth very little marks. And you don't have to do as much as this. In the assignment, I would just add it for anything that actually needs it. Like all this stuff is kind of already specified here, so you could probably just remove it and remove this comment entirely. Do you have a list of Java extensions, VS Code extensions that we should get? VS Code extensions. I have way too many, but the ones I actually find useful. I love. What is it? Error lens. This is beautiful. This is the thing that shows those errors. Do you see those errors that pop up that like show them in real space? That's called error lens. It's very, very nice. I remember someone told me about that. And there's a few other ones here that I kind of use sometimes. I've got some of my own ones that I've run because they're nice. But typically that's the big one is error lens, the one I use a lot for this. I got a couple of JavaScript ones if I'm writing JavaScript, but other than that, it's pretty simple. So that's basically it. Anyway, I went a bit over time. Oh, I do want to do toString. Let me just quickly do the toString. So if I want to do a toString of a manager, it's just going to say, well, what is it going to say, right? And so the question about a toString here is, if we have a manager here, what behavior do we want to add to it? And so typically, it's quite common. Let me just generate one. Let me generate one employee, for examable. I can show you what generate one looks like just because it's a good example of it. And we'll save us a bit of time. Generate to string. Yep, sure. Everything can be included. Don't know why it loves to do that, but sure. And we'll track this down here. You can see it says the type of class name. It adds a bunch of properties to the end. But do you know what I would seriously do? I want to reuse this. Because in my manager class, these properties also exist. I don't really want to rewrite that. So the way I would typically write this, and this is kind of a hint for the course, is this dot get class dot get name. There we go. I was a bit scared for a second. And I would probably also chuck this in the next line and write it like that. Make the lines a little bit nicer. Separate it like a good point. Probably here. Like this. And then I would also probably bring this down like this. And so you just have like a somewhat nice structure reading it. It's being a bit perfectionist over it, so it doesn't really matter. And so the idea now is that you have a pretty nice structure. I'd probably also remove this end bracket, because to me the brackets don't really matter, and it makes it a little bit nicer if you're going to have extensions to it to like add onto the end. But you could also just like add an extra set of brackets for like extra parameters. And so what you could do is you could say like these are the employee parameters, then you could have another one for the manager. But the benefit is now when I do it define it in the manager, let me just comment this out so I can actually generate it. Source action, toString, right? You notice it says manager has no properties, but it has tons of properties. So what I want to do is I want to call the super constructor, which will add my class name because it's using the class name, not a specific or hard-coded name. And the class name is not this name, which is kind of confusing. And we're going to talk about that next week because you don't have time this week. But basically, it's the difference between kind of the perception of the class or the view of the object versus what it really is. And if you're kind of looking into that, you can think of like C, right? So in C, for example, you have like an int pointer, like that, right? And what you want to do is something you may not know that's integer. N equals 2 int n pointer equals n. Is you want to change it to a float pointer. I mean, you can't really do this, but you can try. It's technically not that defined, but it's fine. You can just define a float pointer class like this that will grab the int pointer and convert it to a float pointer, right? And so what you're doing is the data isn't changing here, right? The data is not changing from here to here. If you have not done 1521, you won't know this. But when you're doing class like this, the data is not changing. And the same thing's happening here. So what's happening is you're having a view of the class. And so the class is still a manager. But what's happening is the compiler is saying, well, now I want you to look at it as if it's just an employee. And so what that means is inside the employee class, all we can do is access employee functions because that's our current view of the class, right? So when we're here, all we can do is access employee functions. But it doesn't mean that it's an employee. It just means that's our view of it. That's like our kind of our window. We've kind of drawn a window around it. Anyway, let's not go into that. That's everything. Yeah, awesome. And so that's kind of how I would define this stuff. Up to you how you want to do it. But for the sake of this sanity, let's just do that. And then we could add like extra properties here, right? Sweet. Let's end this here.